Hello everyone, I'm Dominik. I work at TOG. I'm also the committer of Apache Aries, and today I would like to talk with you about object-oriented programming, and especially want to focus on the principles of that paradigm that we very often use in our daily basis job, but we forget about those basic principles that we should always know. Okay, let's start with the quick definition at the beginning. What is object-oriented programming? If you look at the Java tutorial on the Oracle website, you can find out the analogy with the real-world object, like your dog, your desk, your television set, whatever you have in your neighborhood. And based on that idea, you can find out that those objects have some kind of state and also some behaviors assigned to them. And based on that, you can craft your own objects in your software, also mimic those state parts and the behaviors in your code. So you are creating objects, of course, defined in some classes, with some state hidden in fields, and also with the behaviors in some functions, methods, depending what kind of what programming language you are using. So your programs are a set of simple objects, and it's nice to think about those simple objects as small computers. And of course, those small computers have to interact with each other. So for that, you have to call the method of another object that you have created. And if you think about such methods, you can also think about that as passing a message, sending a message to another object. So isn't that simple? Probably, yeah. That's why we need to have some additional rules which are helpful. And we have some principles that are assigned with that paradigm. Those principles are really helpful to design and organize classes in our code base. But this is not only working on the level of classes. We can take advantage of most of these principles on the level of creating the modules, also microservices, or even whole systems that we are trying to implement. And of course, in that principle, those principles are very often grouped in some sets. For example, object-oriented programming principles is one big, very basic group where we have the encapsulation, abstraction, inheritance, and polymorphism. Those principles will be the guides for our presentation today. Additionally, we have solid principles, and solid is the acronym created from the first letters of the principles in that set. We also have grasp, which is more the umbrella name for several other principles that are grouped in this set. Additionally, we have some more principles, but they are not creating any bigger group. They are just named, and I will mention them during that presentation. OK, let's start with the first principle of object-oriented programming, encapsulation. When you read some tutorials about what is encapsulation about, you will find out that this is mostly about information hiding. But you can also it's not only about that, it's also about grouping the data together. But the best approach how you can tackle this principle is that you should build a capsule inside your software. If you do so, if you create such kind of capsule, you are heavily reducing complexity inside your code base. Additionally, you gain the security because you are able to protect the things that are inside the capsule from the external world. And also, you are protecting the external world from all the things that you have inside of your capsule. OK. So let's try to implement some first object in during our presentation. And we'll be in domain of tasks, some task management. And that's why we are creating the first object called task. And we have the property name here. After reading the first tutorial, you probably know that this is wrong because you are not protecting this the state in a proper way. And you have to put the private keyword in front of that field. And very often, in a lot of tutorials I have seen, you have the next step. Let's add setters and getters for this field because someone needs to access it from outside. And even if the library is like Lombok in Java, you can use the getter setter annotation on top of the field to generate such boilerplate code, or even use this annotation on level of the whole classes to generate the getters and setters for all the fields that you have inside your object. When I see such code, in most situations, I could easily translate it to code where everything in this class is public. And this is the technical debt that we are still paying for having Java beans in our software, which were quite useful for exchanging data with some UI, with some UIs, or maybe with some other things. So we are, there should be more connect with some kind of structures that we are creating, but not real-world object. I don't want to say that structures are bad. Structures are very good just for exchanging the data, or when we have really functional stuff without creating the object, and this is not, we are not providing our software taking advantage of the object-oriented principles. But in most situations, here we want to create our code in more objective way. And if you look at the structure, you can ask yourself a question: what's wrong with such structures? And let's imagine that they, of course, have some setters and getters. So what's wrong with the setters where you can set something, some variable to one method? The biggest problem with such setters is that if you have a method set something in your object, that this is not the domain name. This is not the this is more the explanation, what is the result, what is the expected result of the change that you are applying on your object, not the real operation that should be applied on your object. And that's why you should always talk with your customers, always talk with some experts, always look more deep in your domain to find the proper operation name which describes what is the real behavior which should be assigned to some objects. On the other hand, you have getters. What's wrong with the getters? If you have a getter which returns the immutable value, probably everything is fine. Here we return some wrapper on task name, and it's immutable, so it's fine. You can even omit the get prefix on the beginning of the method name, but maybe this is some kind of convention. The bigger problem with such getters is when you're trying to return something bigger. Let's imagine that you want to return some list. What's wrong with that code? The biggest problem is that in a lot of situations, what kind of list you are creating? Probably array list. So such array list can be changed by someone who received that list. So you should probably wrap that collection that you are returning, not only array list, but all the collection which are mutable, should be wrapped in some unmodifiable list, because you don't want anyone to change the order on that list, maybe add something to that list, or maybe remove something from that. Even if you protect the invariants on that list, you have also the problem with the items that you have on the list. So you should also return some copy of the elements that you have on that list. OK, so our collections in some way are protected with such getters. We also have the problem with the getters which returns the value that could be available or not. And the problem with such getters that probably your IDE will generate on some keystroke assigned to the generating such boilerplate code is that you are not expressing that the object that you are returning is optional. So starting from Java 8, we have the optional type, and we can wrap the return type in the optional. And of course, I have done this in this getter, but you can also think on that on another level. Let's imagine that we have the optional fields. Of course, that will be a lot of mess that we shouldn't do so, because optional is not designed for being a field inside our objects. But if you are creating real capsule in your code, and it is helpful for keeping the invariants inside your object, what's wrong with that code? If it works for you, it's only the matter how you design your capsule inside, and outside, it shouldn't be visible. The problem also with such fields and getters and setters is strongly visible when we try to rename a field in our code base. Let's imagine that with your favorite IDE, you start with the rename field button. Probably you will be asked about renaming also the getters and setters inside your code. When you change them, probably some variable names or parameter names that are passed or retrieved from those methods should be also changed, but it very often comes with some code review. And after such changes, you can find out that there will be a lot of changes in a lot of places among several files in your code base. And this is not the way how you really should encapsulate the stuff. On the other hand, when the software when the object properly encapsulate the state, you will have the changes only in maybe one file, maybe two files when you also have some changes in tests or maybe in some object who calls your object. But there won't be a lot of changes in several files. That's why when you are creating the software, when you are creating your object, you should not focus on those fields. Those fields are only details. The more important part is how you design the methods which are exposed by the capsule that you are creating. So from our task class, we should more be sure that we are exposing only one getter, and this is it returns some immutable value, so we know what we are doing. And we have more domain operations, like assign to, resolve, reopen, and so on and so forth. I also want to mention here the topic of the visibility. When you create a field, probably you know that most of the fields should be private. In some situation, they could be protected if you want to support inheritance. On the level of methods, most of the methods should be private. Why? Because in our daily basis, we should follow the clean code from Uncle Bob. So we are creating a lot of small methods inside of our object, and most of them should be private. Next choice is to make them package private. And only when you really need, you should make them protected or public. But this set of really exposed method should be as small as possible. And the same is on level of classes. Most of the classes should be private when they are internal, and when not, they should be package private. This is the default modifier in Java. And only when you really need, make them protected or make them public. And don't write the code which needs to use the annotation like visible for testing. There is always a way how to abstract the thing that you want to create to avoid such annotations at rises of the modifiers, of the scope of the functions that is exposed from your objects. OK, and it leads us to another principle of object-oriented programming, abstraction. When you look at the abstraction, the first thing which comes to my mind is we should create object with good APIs in our system. But it's something bigger. We should always think about our software that implementation that we are trying to mimic in that changes very rapidly. And something which stays with us for much longer time is some kind of abstraction, some kind of bigger picture that we extracted from the model that we have created. And that's why we should hide all the unnecessary information through that abstraction. And also, even we should omit some unnecessary information because no one wants to take them from outside. So why we have to keep them in our software? That's why we should expose only the essential information from our object, and all the other things should be skipped. When we do so, we are improving heavily the readability of our objects and also the code that we are creating. And also, this is the way how we can hide all the complexity of surrounding world that we are modeling in such abstractions. And of course, when we want to do so, there are another principles which are helpful. So we have the principle in Grasp called information expert. This principle is about delegating responsibility to the object who has most or all the knowledge which is necessary to perform some task. Let's imagine that we have created some Java bean called task, and from that we get some status, get assignee, and based on those two variables, we make some condition, and at the end we return some. Maybe we update something, maybe we change something, we don't know. And when you look at that code, you see that the task class has all the information that is necessary to perform the action. So maybe we should rewrite this code in such way where you ask an object that maybe you can be reopened, and if so, I can apply some action. The code looks a little bit better, I think, but the next step is following the tell, don't ask principle. This principle is about that our object will probably also have to check all the invariants, and that's why we don't have to ask him, Can I change something? No, just send the message. Let that task be reopened. And the task class will respond, the method reopen, will respond with maybe false when the operation failed, maybe with the exception. And when the operation will be fine, we'll receive true, maybe new version of task when we model our code in immutable way. Or maybe there will be no news, because no news is good news. But if you want to apply this approach, you have to keep your object always in a valid state. And because of that, you should have as quick validation as it possible. For me, it's really painful when I see a code when we make some changes on some object, and at the end or in the middle of some operation, we ask this object, are you still OK? No, if it's not OK, tell me instantly that something went wrong, and I will recover from that situation in my code base. And that's why in all the methods and also in the constructors, we should validate all the incoming parameters and always validate also the state that you have inside your object. And that's why and that's how you are creating the information experts. But you should also respect that another object are also the information expert. And that's why we have the law of the matter. This principle is about not talking to the strangers. Let's imagine that our task class in some specific domain or subdomain will have property logged work. And when we want to add something to that log some work, we shouldn't use code like that, where we get some work items. Maybe it's list, maybe it's not, but we have the add method and we add some element to that list. Instead, we should respect that our logged work is a separated object, so let's call the logged work on that, and it will be the duty of our logged work to not only create the object, but also to store it in a proper data structure. And here, our logged work could be the example of creator in terms of grasp. And probably when you hear about this principle, about this pattern from grasp, you instantly think about the factory. But this is something bigger, because you can also create some local factories. And our log work that we have in our logged work class will be responsible for also creating the work items, and it will be a kind of small factory for which elements that this class is creating, this class also will be responsible. And sometimes when you have a set of such information experts and we respect each other, we have to there could be a problem that we don't know where to put a specific operation, where to assign a specific behavior. And that's why we have the pure fabrication pattern from grasp. And mostly this feature, this principle, is used when we are creating domain services, or maybe for us, it could also work in a lot of situations when we have to use some kind of util. Let's imagine that in discussion with some customer or expert, we find out that when we have a set of tasks or some list of tasks, we have to calculate the final estimation of the task that we have. And the behavior is described by the expert, but the name, task estimation calculator, is some fabricated name which we only need to make some holder for those operations and not break another principles like law of the matter and also the information expert. Also, we want to express something like that in a separate classes to not break the single responsibility principle. This principle is about creating classes and also methods that have only one reason to change. It doesn't mean that they are doing only one thing. They are responsible. They manage only one thing and should do it well. For that, we have to fight for a high cohesion inside of our software, inside of our classes. So cohesion is a way of measuring how much elements in the module, in the class that we are creating belongs together and how much they have to be used together in our software. And here we can take advantage of some IDE hints or maybe with some static analyzer hints. And those metrics, those hints are mostly based on one of the metrics that I want to mention. It's called lack of cohesion of methods. This this metric is abbreviated to lcon4 because this is the fourth version of the metrics, and it describes how many clusters of methods and fields we have in our class. So when the lcon4 is equal to 0, we don't have any methods. If the lcon4 is equal to 1, this is the perfect situation because all the methods and all the fields are in some way have to be used together in some way. And when the lcon4 is bigger than 1, it could be a hint for us that the class should be split into several other classes. But what is worth mentioning, it's maybe not about the methods, it's more about the behaviors that we are exposing, because we shouldn't count constructors, hash code, equals, toString, and several fabricated methods, because they are not expressing the real behaviors, and they very often create one clusters of fields and methods inside of our software. That's how we create the object inside. But outside, in a communication with another classes, we are fighting for low coupling and trying to achieve it as low as possible. Of course, we cannot achieve it on the level of 0, because then we won't have any connections between classes, but it should be as small as possible. Coupling is a way of measuring how strong one element is in relation with another one. Maybe it uses another object, maybe it knows about the existence of another object, maybe it relies on some specific state, order of execution of another object, and so on and so forth. And when we minimize the dependencies, such coupling in our software, we are minimizing dependencies between classes in our code. And also the changes that we are applying to those classes can become more local, more focused on our capsule, not on surrounding world. And also such components, no matter if it's module or class, they can be easier to reuse in several contexts where they fit. And here, we also have a very helpful technique and very old technique called CRC cards. CRC stands for Class Responsibility Collaborator, and this is a small piece of paper, so you can take advantage of this technique even without writing a line of code, where you name something, some kind of class, but you know that this is a group of objects, and you write all the responsibilities of that class or that candidate for class, and also all the collaborators, not the fields, but the collaborators with who you have to interact to perform your actions. And if one or second list grows too big, then probably you have to untangle this class and make several other classes. And how to do so? We have also here another helpful technique, another helpful principle called dependency inversion. Dependency inversion from Solid is about creating high-level components which are independent from low-level components. Or on the other hand, we should depend on abstraction in our software, not on concrete objects. Let's imagine that in our task domain, we have created some kind of task service. For us, it will be the controller. But this is the controller in terms of grasp. So as each controller, it's a kind of dispatcher, but it's not the same as controller in terms of MVC. We are not working on the level of HTTP. We are working on the level of some routing inside of our business logic. And our task service is a kind of concrete object. And for such concrete object, we want to express some higher abstraction. That's why we can express some interface which could describe some business use case that could be available from our domain. So we have the task other interface created. We can create such indirection in our software, which is also the pattern in Grasp, by using the interfaces, and also with most of the design patterns that we can find in the Gang of Four book, like in adapter, bridge, facade, or mediator pattern. You can also find the interfaces which are pretty useful to express such higher level concepts. And we, in our domain, still have to perform the adding task operation. We have to interact with some external components, like some Rabbit message broker, maybe with some JPA task repository. And those objects are more concrete. They are connected with a specific infrastructure layer, how we interact with those external components for us. And that's why you are creating very often the interfaces like event sender and task repository. On the other hand, someone has to add a task to our system. That's why we expose the MVC, real MVC controller, which we call the task controller. But this is not the only way how you can add the task to your system. You can also take advantage of some events, and based on the event, you can also add a task. And if you create a software in such a way where you express, say, higher level interfaces, you can create the boundary around those things. And this is the example of hexagonal architecture, which is pretty useful for especially the domain-oriented software that we can create, where in the middle you have your domain code and also the application services working on such domain code. You have the boundary on ports around that, and you also have some kinds of adapters, which allows you to interact with some external words elements like HTTP, or maybe with some databases, and so on and so forth. And when we are creating such abstractions, such higher level components, we should avoid leaky abstraction. Let's look at the examples of leaky abstraction in Java code that we have from the providers of the JVMs. So here we have the collect method at the end of some stream, and when we pass a specific collector, for example, get from collectors by method to list, you receive a list, and if you try to add something to that list, everything will be added to that you need will be added to such list. But the bigger problem is when starting from Java 9, you can start to use the method to list. At the end of stream, of course, instead of collectors. The list that you received, when you try to add something to that, you will receive the exception. And it's because the list which was returned is immutable. The problem is that in Java 17 and also 18, this interface has more than 20 methods. Some of them are, of course, inherited from another interfaces, but let's look at the list interface. And if you look at the methods here, you have the methods like contains, size, or stream, and they are pretty useful for all kinds of collections or lists that you have. But you have also methods like add, remove, set, or clear. And those methods imply that your object is mutable. And in a lot of situations, it's not. That's why you should follow the interface segregation principle, where you should create a small and concrete interfaces. And it's always better to have one method interface with 1, 2, maybe 3 methods, which express one thing in a correct way, than having a lot of one big interface with a lot of methods inside, because there will be always someone who breaks some rules that we stated in those methods. Okay, it's about the abstraction, but now let's move a little bit to the next principle of object-oriented programming, which is really connected with the abstraction, and it's inheritance. Inheritance is a way of creating new classes based on another ones. So you can still take advantage of the task class that we have created at the beginning, but for some specific methods, behaviors, or maybe to have some additional state, we are creating the programming task and also the research task specific classes, which extends the task class. If you don't want to allow for using the base class, you can make them abstract, and you won't be able to create the instances of that class, and you will always have to create more specific tasks. No matter what type of inheritance you will choose in your software, what type of design you will choose, you should follow the risk of substitution principle. This principle could be described in 2 statements. Don't surprise me and respect the contract. Because the principle here is about creating specific classes that can be always used in the places where the base class is defined. So let's imagine that we have created our task class, and it has the estimate method. It's abstract, it returns only the estimation, that all the information that we have in that class. And now, let's imagine that in our calculator, we call on some stream operation estimate in some maps, and we reducing it to the final estimation for all the tasks on that list. And now, when some nasty developer will add new version of the task class, new specific task class, and implement the operation. Instead of returning some value, we'll throw the exception or return null. We can find out that it will be pretty destroying for our calculator. And that's why we are breaking risk of substitution principle, because we made something which is not stated in the contract. But this is also the matter that our base class is not well designed. And that's why we have open-close principle. This principle is about creating the class, method, or module that should be always open in some way for extension, but on the other hand, there should be always closed for modification. So we can take advantage of this method, but we shouldn't change the code. We shouldn't go to there and, for example, change the signature of the method and so on. And when we want to follow these principles, we should protect variations inside of our objects. What does it mean? It means that we should identify possible changes or instabilities, especially in the API or the model that we are creating. And around those things, we should create the stable interfaces. So now, when we have a little bit of digging how the estimate method could be used in our software, we will know that we should express that the optional will be the better return type, because we will have only one way to express the missing value inside of the task class. Here also, we should fight with the leaky abstraction that very often occurs when we have a problem with risk of substitution principle and open-close principle. And let's imagine that we still want to use the external task in a previous version, and then we'll have to have some explicit branch for handling the external task, and where we will have to call the estimate method in some try-catch. And for all the other cases, we can take advantage just of the estimate method, and we know that the value will be fine. The problem here that I want to mention is with the sealed classes. Sealed classes are classes where, on the level of compilation, compiler will already know all the possible specific types of the class or maybe of the interface. But let's stick for the class. So we have created the status class, and it has two specific types: success and failure. No more. And the problem is when you starting from Java 18, as far as I remember, you can create a switch statements like that. And the problem is that when you do it locally in one module, maybe really close to the status class or inside the status class, it's fine. But if you have to use this pattern in several places amongst your system, this is the sign that probably something is wrong with your design, because adding new type, new specific class will have to change. After such add, you will have to change a lot of places around your system, and it will cause a problem. Okay. Also, the problem with the leaky abstraction for me is unnecessary abstraction. And to make some examples of that problem, let's look at the object class from Java. It has a methods like equals, hashcode, and toString. And if you really want to use those methods in your code, the first thing that you will read in the tutorial is you have to override them, because their default implementation, are not useful for 99% of the cases that you need. And I would prefer to have the interface supports equality, which even with the generic, and also the supports printing, which will be describing that my object supports those things, not that I inherited the methods from the base class and I always have to override them because someone created such methods in the base class. Okay, and when we have so many problems with the inheritance, when you look at all those principles, and you should ask yourself a question: maybe I should prevent inheritance of my class. And remember that allowing for inheritance, it's your design decision. So that's why you should always decide what and how can be specialized in your classes. And maybe the good call will be to create your classes with the final keyword at the beginning, not allow to extend it. If you really need to extend a class, remove the final keyword in your code base and keep the move the final operator on the level of the methods that you have, and only for the methods that should be really extended, you make them not final. I really like the Kotlin approach, where everything is final until you use a specific all-open plugin for compiler, but this is another topic. And here, all the classes in Kotlin are final by default. So you have to explicitly tell that I want this class to be open, and then I want this method to be open. Without that, everything is final, and we don't have a lot of problems with wrong implementation of the classes, of the specific classes, which were not designed for being extended. Okay. But why we still stick with the inheritance in our software? I think it's mostly connected with the rule called "don't repeat yourself." This rule, we very often, when we read this rule, we think we should not repeat a field groups. We should not repeat some behaviors. But it's something bigger. If you have the same set of fields or the operations which looks the same, it doesn't mean that this is the same. You should think about some business concept that you are trying to abstract in your software. And only for such things, for such knowledge that you find out in your project, in your system that you are modeling, you should create single representation. And that's why you should ask yourself a question: is the inheritance the best way to express that? And I like the quote from children who say, this is the same, but different. And you should always, on some kind of scale, put the same and different and check how much really the base class is close to the specific classes that you are creating. Because remember that inheritance is a specific form of coupling, especially in Java, where you have single inheritance, and hierarchy of classes that you are creating could be seen as a little bit linear, yeah? So this is a really big problem, because the coupling between the specific class and the base class is really, really big. That's why maybe you should consider another option. So we have the composition, for example. Composition is, of course, using another object to express my behavior in my code, in my object. So you combine some other objects together, or you can decorate and delegate some of the things only to one object that you are wrapping. Let's imagine that in our software, we have the interface as tameable. Maybe this is not a correct name, but let's stick with it. It looks like a kind of convention in Java. And we have only the definition of the method, only the declaration of the method estimate here, and our class, task, it could be even final, and it implements this interface. And we can take advantage still of this class, even if it's final, and create, for example, external duty class, which implements this interface that we have created previously, and wrap this class in wrap the task class here, and we don't care that it's final, and we still created some kind of abstraction in our software thanks to the interface. That's why I think that the good interface is sometimes good enough in our software. And also there is a rule that says we should prefer composition over inheritance, because inheritance is really hard to untangle. Composition is something much, much easier to use in our software. Okay. The last principle of object-oriented programming, which is strongly connected also with the inheritance, is polymorphism. Polymorphism is also a pattern principle in Grasp, and in Greek, it means many forms. So what can have many forms? It's about one method name that brings different functionalities in our software. So how can you distinguish between those functionalities if you have only one method name? It's because you have the type system in the object-oriented programming languages that supports this paradigm. And you have two possible manifestation of the polymorphism. You have overriding, where in some base class you define a method, and in some specific class you override this method, and you even have the annotation here to express that this is the same method name from the base class that you are overriding. And when you, in your runtime, you want to take advantage of the task class, the runtime will know what is the specific type of the task class and call the specific method. The second manifestation is overloading. Overloading is when for one method name or the constructors, which is a specific type of methods, you have different parameter list in terms of types. So for example, you can create a task from some sample. You can create a task only with name, maybe with name and also some labels. And this is the great way to simplify our API and still stick to the domain names that we find out in our system. This is also the way how you can introduce some default values that you know that are best for some of the parameters that you need. And for me, this is also the great way of evolving the API in our software. Because let's imagine that our task class always had the finish method. And it is parameterless, so the moment of time when the task was finished was always created from some static factory. If you wrote at least one test, probably you know that it's really hard to test in the software. So you want to express that this parameter should be derived from provided from somewhere else. And also it's really helpful, for example, when you want to finish a task based on some event which contains such a moment of time. So you are writing the next method, finish, with the instant when parameter, and your previous finish method can just call the new method with some default value. And of course, you know that the first method should be avoided, and maybe you should make it deprecated. And your IDE will guide you how to remove, in a lot of situations, such methods in your code base. Even in Kotlin, it could be done by the annotation is so great that it could replace the code with one click in the IntelliJ IDE. But this is the feature of Kotlin. This is great language, by the way. Okay, so you remove that parameterless finish method, and you went only with the new version. The evolution is done. But remember that if you apply such evolution in your software, the overloading is not a silver bullet. If you know the better name, if something changed inside that method that is not correspond with the method name that it had previously, then probably you should use the better name, even if it's convenient to reuse it in such way in some API and it's helpful at the first sight. Okay, that's all the principles that I have prepared for you for today, and I want to now leave you with some key takeaways from this presentation. First, hide all the details or omit all the details and make them hidden inside the capsule that you are creating. Expose only the necessary information and also operation outside of the capsules that you are creating. Know the rules, know the principles. As whole, they make real sense, but still, they are only principles. They are some kind of guides for us, and they are not enforced by the compiler by default. Of course, you can add some plugin for compilation, but because they are not enforced, you should always know and why you can break those rules in the software that you are creating. Maybe for the case that you are resolving, maybe omitting some of those principles will be helpful for you. But you have to think about that. That's why, the last thing, you should not write your test. It's not that your IDE makes everything public, make all the classes public, make all the things open for extension, makes all the things, all the methods public. You have to look at each class and design it, not only just write the next class because I think that we need another one. Okay, that's all from me. Thank you very much. And if you have any question, then Slido. Thank you very much. Okay, do we have anything in Slido? I don't see anything. Or maybe there are the question. Okay, what's the question? No, I haven't heard about that. Thank you. Okay, we can talk a moment about that after the presentation. Okay. For me, seems that seed classes violate OCP. What do you think? Yeah, for me, the seed classes violates. It depends how you use those classes. Seed classes are pretty, as I stated, they are nice feature when you are able to make them inside one module. Take advantage of those specific classes inside of the object that you are creating. But if you put it in several places amongst the whole system, this is the bigger problem. So this is the double-edged sword for me. Okay. Doesn't validation in example setters, which you suggested, break the principle of good method naming? It's not the set name, it's set name and validate. Yeah, I'm more encouraged not to use setters at all. So this is another topic. And yeah, but this is also the good case that we are not only setting but also validating. Maybe we also do a lot of other things, and maybe we don't even think about that, and the setters are not the real setters. Okay, entities should take care about the validity by themselves. What if you need external services for validation? Yeah, hard topic depends on the situation that you have and what kind of validation you have to perform. And there is some kind of approach where you are creating the object that you really treat as data structure, and you apply some kind of service which performs some validation, and then instead of only validating this object, it creates the validated object, which could be the proper created object. I hope it's answered this question. Okay, do we have any other question? I think no. There is no questions from the audience. Thank you very much.